Hello ladies and gentlemen, today we are going to be examining measuring angles, and in particular we're going to be looking at measuring the angles with a protractor, doing some equations with them, and we're going to be looking at how to name angles. So first, right off the bat, if we want to name an angle, similarly to how we named planes, we're going to go ahead and use 3 points in our angle. All angles are always going to start with an angle symbol, looks kind of like that. And the middle letter is always going to be what's called the vertex. The vertex is a pointy bit of an angle. So I'll give you an example here. A surveyor is recording a bunch of angles formed by a transit, and they're located at point A, and they're looking at distances B, C, and D. You might have seen surveyors in the past if you've ever gone to any construction area. You've probably seen surveyors with the tripods looking through some sort of lens and identifying elevations in various places in the distance. If our surveyor is located at point A down here, all right, point A down here, I want to generate angles that have A as a vertex. So one of our angles clearly is going from B to A over to D. There's a relatively big angle. A is our vertex, and we can go ahead and name this angle angle BAD, angle BAD, with an angle symbol. If you'd like to reverse the order, that's totally fine. You could call it D to A to B, and that would be a perfectly valid angle as well, D to A to B. Do note that I cannot name this angle, let's say DBA. Even though we're using the same set of letters, right? We're using the same set of letters. DAB would look more like this, from D to B to A. It's a completely different angle as our B to A to D angle. Critical is that the letter A is in the middle, and it's the vertex. A few other angles we can name. We can go ahead and go, let's say, from B over to A over to C. And similarly, we can reverse those, CAB. That is angle CAB, or angle BAC if you prefer. Last but not least, let's go and switch over to another exciting color, let's say green. I can go ahead and go from C over to A over to D, or DAC if we'd like to reverse the order. Those are 3 angles that I can make. All of these angles are obviously different sizes, and we measure them in degrees. You're probably already familiar with all of these terms: acute, right, obtuse, and straight angles. But I'll go over them really quick here. Let's say we have an acute angle with a point S, a point T, and a point R. We'd say that any angle that is less than 90 degrees is going to be an acute angle, and we'd name this angle angle STR, or if you wanted to name it, you could also name it RTS. Either way is fine. Right angles, on the other hand, as you probably well know, right angles are any angle that makes a 90 degree. You can name it whatever you like. I'm going to let you put your own lettering in on there, but it's any angle that makes a 90 degrees exactly. Obtuse angles, you've probably already guessed it, are any angle that is greater than 90 degrees. And last but not least, any straight angle. Oh good, I have pink in my repertoire, that's exciting. Any straight angle is going to be a straight line that's going to be exactly 180 degrees. Now I would like to clarify something with the obtuse angle. Not only is it greater than 90 degrees, it is less than 180 degrees. All right. Larger than 90 and less than 180 degrees. So it could be anywhere 100, 110, 115, 20, whatever, all the way up to 180. There is one last type of angle that we will look at a little bit in this course, but not very frequently. Something called a reflex angle is any angle that is larger than 180 degrees. That would be as if you took an angle and you measure the outside of it. It might measure 250 degrees. Luckily in this class we won't be looking at that too much. Instead, we are going to be looking at the interior angles that are all going to be smaller than 180 degrees. Let's look at building some of these angles, and particularly measuring some of them. Suppose we want to measure an angle EOD. All right, that references this angle down here, E to O to D. I want to know how big that angle is. Well, eyeballing that angle right away, I would approximate that that angle is about, maybe 100 degrees. It's at least larger than 90. If we'd like to measure that now, all of our angles are out, or the most common tool that you're going to use to measure these angles is called a protractor. Looks something like this on your screen, measures anywhere from 0 to 180 degrees. I can make this a little bit bigger, a little bit more visible. I noticed that EOD is kind of an upside down angle. I need my protractor, the center of my protractor here, to be able to fit exactly on the vertex in this horizontal line to follow OD. So I'm going to go ahead and flip my protractor upside down as soon as I figure out how to do that. There we go. Protractor's flipped upside down. I'm going to place my protractor right over the vertex so that my line, my horizontal line, is matching up with OD. And I look now to see where the other line right here, where the other line is pointing. I see that O to E is pointing somewhere between either 70 or 80 and 100 to 110. Which set of numbers do I use? Well, if it's obtuse, I'm just going to use the bigger set of numbers, all right? It's an obtuse angle. It's got to be bigger than 70 or 80, right? So I can go ahead and cross those off and say, well, it's going to be between 100 and 110. Looks like it's pointing about to 105 or so. If I extend that line, it points to about 105. So I'd say that EOD then is about 105 degrees. And to classify it, I would say that this is definitely an obtuse angle. You can do similar things for your other angles as well. For example, DOC, if you want to measure DOC, you would just flip your protractor back right side up and then solve that and realize that that protractor indicates it's about a 30-degree angle or so. COA is very clearly a straight line. It is a straight angle. It's 180 degrees. And AOD, you can go ahead and measure with your protractor by flipping it around once more. I'm going to skip example 3 and in favor of example 4 because they're very similar to one another. But first, a definition here. Last time we talked about lines. Lines go forever in 2 directions. This one is a little bit better, named after a famous band, of course. This thing's going to go forever in 1 direction, and it's called a ray. Right? A ray goes forever in 1 direction. Good band. Now, a ray, we see rays pretty frequently. Actually, every day we're going to see sun rays, right? We see sun rays off in the distance. The sun is shining. It's letting off rays every which way. And us over here are receiving those rays and absorbing vitamin D. Unfortunately, that's a bit of a misnomer. If you're not familiar with that term, it's kind of misnamed. Sun rays, they start at the sun, they hit our eyes, they're done. Technically should be called sun segments. I don't know why we don't call them sun segments. That's their proper name. Perhaps it doesn't sound nice in a lovely love song. Perhaps if you wanted to sing about your love sun segments, that doesn't, or sun line segments, it doesn't sound quite as beautiful as sun rays. Who knows? I'm not sure why exactly we use that. Oh well. But we're going to use rays. So ray EF, do notice that in the naming convention here, EF has a arrow that is pointing off to the right. That means it starts at E, shoots off towards F and beyond. EF is in the interior of DEG. Let's look at that word, interior. It means on the inside. It's on the inside of DEG. All right. It's on the inside of DEG. I'm going to go ahead and draw angle DEG. I am given information that DEG is a 115-degree angle. So I'm going to approximate that. You could draw it with a protractor if you like. And I'm going to go ahead and draw ray EF after I label my points. Here's D. Oh, bother. Let me draw that back once more. 115. Here's point D, here's point E, here's point F. We have a ray EF that is going off in some distance. Ray being in the interior, it could be up here, could be down here. There are a lot of places this could be. Note that we're given that it's 48 degrees. So I'm going to draw it so that it's approximately 48 degrees. We'll label that. The question here is, how big is angle FEG? From F to E to G, I should indeed draw the G as well. What am I doing wrong? I'm doing something way wrong. Excuse me. This angle DEG, this should be a G. E to F is in the interior. F is actually a point up here. Excuse me on that. E to F, let's make sure we have it right now. E to F, EF is a ray that is in the interior of DEG. Yes, looks correct now. And DEG is 115 degrees. DEF is 48 degrees. Excellent. Question now is, how big is FEG? From F to E to G, I'll switch over to my lovely pink. We don't know how big that angle is yet. We want to know, well, the whole thing's 115. This angle's 48 degrees. If we want to find FEG, the measure specifically, note that little m stands for measure. The measure of FEG is equal to 115 minus a 48. If we subtract those two numbers out, that's going to be a 67. Let's check that real quick. 67 plus 48 going in reverse order. 6 plus 4 is 100. 7 plus an 8 is 15. 115. Awesome. We are set. We'd say that measure of angle FEG is 67 degrees. Now for our last problem. KM bisects JKL. If you have any siblings, you're probably well familiar with the concept of one kid cuts, the other kid chooses. If you need to split some cake, split a cookie, etc. It's a reasonable thing that basically says you have a piece. One kid cuts, the other kid chooses. You want to bisect something exactly. You want to cut it exactly in half if you're that child and you want exactly half of a piece. Well, we can cut angles exactly as well. Suppose we have an angle, and I'm going to draw this angle kind of like that. I'm not sure how big the angle is yet. I'm given a bunch of equations with some x's or expressions rather with some x's. I don't know how big it is yet, but I'm going to go ahead and label my points correctly this time. We have point J, point K, and point M. If I want to bisect something, I obviously don't want to cut things right here. That's not where half the angle is. I don't want to cut things over here. I want to cut things about in the middle so that on either side is an equal angle. I'm going to cut that with a ray that goes through point M and beyond. I'm going to label my angles now. So I'm going to say this one is a 4x plus a 6. This one is a 7x minus a 12. Now what can I do with these equations? Well, I got to ask myself which angle's bigger. They're both the same. They're both the same because we know it's bisected. It's cut exactly in half. What can we do when things are the same in algebra? We can set them equal to each other. So I'm going to go ahead and do that. 4x plus 6 is equal to 7x minus a 12. I'm going to do something that we didn't do last class, which is do two steps at the same time in an equation. I'm going to subtract a 4x from both sides. All right. In addition to that, getting all the x's on one side of the equation, I'm also going to add 12 to both sides. So I'm doing the same thing to both sides, subtracting a 4x, adding a 12, but I'm doing both steps at once to save a little time. On the left side, I have a 6 plus a 12 remaining, giving me an 18. On the right side, I have a 7x minus a 4x remaining, giving me a 3x. If I now go ahead and divide both sides by 3, I find out that x is going to be a 6. Now, am I done with my problem? We do have an x value. In algebra, we would be done. But let's look at the problem. Find angle JKM. We don't know how big angle JKM is yet. I'm going to take my 6 that I have for x then, place it in for angle JKM that we have here, and I'm going to say that the measure of angle JKM is equal to 4. Instead of the x value, I'm going to put in the 6 plus the 6. 4 plus 6 is a 24, plus another 6 is a 30. We'd say that JKM is exactly 30 degrees. Now you might ask yourself, well, is Mr. Reece's drawing correct? No, it is not actually correct, and in that I just erased it. Goodness. No, it is not actually correct. A drawing that big is clearly not 30 degrees here, but I didn't know initially, so I'm going to go ahead and just say that's a reasonable answer. I didn't know ahead of time how big the angles were. I drew them willy-nilly, and if I were to redo this problem, I would probably draw the lines in such a way that we have approximately 30-degree angles instead. As always, let me know if you have questions. Have a delightful day.